typical sort of problem that you'll be given involving scale factors and similar shapes is, given that two shapes are similar, can you find the missing side or dimension of the second or the first shape? So let's see how this works by doing a very quick example. We're given a rectangle and we're told that it has sides of 3 and 2 units. There is a similar rectangle to this. Similar meaning similar shape, obviously. It doesn't have to be exactly the same size, and we're told that one side is 3, the short side, and the longer side is the one we don't know. So we're going to have to find out what that longer side is. Now, if we're told that two shapes are similar, what does that mean? What does it tell us? First of all, it tells us that all the angles are the same. And secondly, it tells us that the ratio of the sides is the same. It's the ratio of the sides being the same that is probably more important to us in this case. So if we look at the two shapes, we know what the short side is in both of them. And so we will know, because they're similar, that the ratio of this side to the new one is 2 to 3. So the scale factor is to multiply up by 3/2. Because they are similar shapes, we know that the long side will have the same scale factor, and that will enable us to work out what that long side is. So the missing side is 3, the length in the original shape, multiplied by the scale factor, which is 3/2. We work that out above, and that gives us 9/2, or a length of 4.5 units. That was a very straightforward example with only one side to work out. As long as you remember that the ratio will be the same for all sides, this can help us with more complex problems. Let's have a look at something a little bit harder now. Let's this time take two pentagons, and with some of the sides given to us about these pentagons, we'll work out all of the missing pieces of information. We're told what some of the sides are on each of the pentagons, and we're also told that shape A has a perimeter of 7.65 centimeters, and we're also told, importantly, that the shapes are similar. Because we know the shapes are similar, we know that all of the angles are the same and that the ratio of the sides is the same. And if the ratio of the sides are the same, then importantly in this case, the ratio of the perimeters is the same. So how are we going to work this out? First of all, we've got to work out the scale factor. We're going to do that by finding two values on the diagram that are the same. And the only two where we can do this is we've got one length on drawing A and one length on drawing B that are in the same place. So we can compare those two and work out the ratio between them. And from the ratio we can work out the scale factor. To multiply up from shape A to shape B is scale factor 2. So we now want to find that missing side on B, and if we knew the perimeter of B, we'd be able to work that out by subtraction. So we know the perimeter from A is 7.65 centimeters. We know the scale factor is 2. So we can multiply 7.65 times 2 to give us the perimeter of shape B. Now that we have the perimeter of shape B being 15.3 centimeters, we can work out that remaining missing side by subtraction. So we subtract all of the other sides that we already know from 15.3 and we get the missing side of 4. We can now work out the lengths of each of the sides on A by using a scale factor of 1/2 to get back from B to A. Remember, the scale factor from A to B was multiplied by 2, so to go the other way we do a multiply by 1/2. And this will give you the value of each side of pentagon A. So we now have all of the lengths of both of the pentagons, which is what we were asked to do in the first place. So this problem, whilst being a little bit more complex than the first one, used exactly the same principles. It required us to work out a scale factor, and then using that scale factor we worked out the missing values that we had. The difference here was that we had to work through several steps. We had to first of all work out the perimeter of the second shape, then we could work out one of the missing sides, then we could work out all of the sides on the original shape. When you're faced with a more complex problem of this kind, it's usually around the mathematical reasoning that you're required to engage in to work out how to get to the solution. Usually the individual steps along the way are quite straightforward and no harder than they are for simpler problems. As with all maths problems, the more you write down, the more of your steps that you note on the question and answer sheet, the more likely you are to make sure you don't make any mistakes along the way.